Hello, fellow Mythrunians. Welcome to another weekly live stream. We're going to be continuing what we were working on last week. I've been working behind the scenes in the meantime, trying to shore up the GOAP library. So in the meantime, so we'll be working on whatever we think to work on. Without further ado, let's go ahead and get started. There's my patrons scrolling up there, the ones who've stuck around. I really appreciate it. Thanks for hanging in there, guys. And yeah, we'll go ahead and get started. I think everything's working. And yeah. So what I've been doing is fleshing out the GOAP API a little bit. Trying to generalize some things. When I started turning the rule sets into graphs, this is what one looks like. This is that making a dagger set of rules we have, and the amount of custom keys and things. And when I actually started trying to create this sort of what I call a real-ish planning test, which is where I create some basic game objects, and I try to create like a real sort of world setup where there's an anvil at a particular location and a forge at a particular location and a chest that actually has objects in it, and another chest, 3 chests, and so then the NPC will have to pick which chest is the best one to get each of the things from. Does he get the hammer and the rod from the same chest, or the rod from one chest and the hammer from another, and so on and so forth, and still got to take it to the forge. And as I was doing this and trying to use real world objects, I found all kinds of things that my GOAP library didn't cover. And it got to the point where I was like so deep in the woods that I even poked around at other GOAP libraries, and they don't really do what I want either. I think I'm trying to do something more advanced than what a typical GOAP library does, because they typically deal with sort of straight local state, not a whole lot of looping or anything like that, at least based on my cursory poking. And so I'm kind of in uncharted territory here. And partly it's like I have a background during part of my career where I did a little bit of work with expert systems, and there's a lot about this that tweaks those same brain cells, and so it could be that I immediately launched into wanting this to do more than what a usual GOAP library does. And in point of fact, Mythruna may not use all of these features. It just it depends. But it doesn't hurt me to flesh them out, because and what I mean by that is, in Mythruna's case, like I said, in Mythruna's case, there's the town management that's on top, that's doing the town level action scheduling, and then there's like the brain, which is what would be calling GOAP. And even within there, there's this sort of signal to goal to actions, right? And it remains to be seen in actuality how much the typical brain puts into this. Like, are we going to tell the brain create a dagger and have it figure out all of the different actions it needs to do to get it from the chest to do this, and blah, 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 the 5 or 6 steps? Or is it just that at the top management level, we know we want this NPC to create a dagger, and therefore he must do these 3 steps. He must get a rod, he must have his hammer, and he must, bang, heat the rod and then bang on the thing. Like, he has 4 steps. There's the recipe for a dagger, right? And the town knows what that recipe is, and so basically the town gives the NPC a series of goals. So his actions are much simpler. He's just got to figure out, how do I get the rod? Oh, I need to look in a chest for a rod. The thing that frustrates me about that is that the NPC who could have otherwise figured out that the rod and the hammer are in the same chest might do dumb things like go to one chest to get the hammer and another chest to get the rod, even though there was a rod already at the anvil, or one in, anyway, he doesn't know what all of his goals are at once, and so he may do stupid things. And so so that kind of thing is my fallback. I recognize that I can do it. I could even insert another sort of strategy layer. The interesting thing, though, is that as this GOAP library develops more, town management becomes a set of GOAP rules. If there's a strategy layer between the town and the brain, that try to coordinate multiple MVCs and things to do more complicated things, it would also be GOAP rules because they're really getting fleshed out well. And kind of the exciting part about working on this in particular is that this is not a temporary system that I plan to replace later. As it stands, this is a core game system that will be in the final version of the game, which I cannot say about a lot of the things we work on. Some of the stuff is there kind of in partial form, but this library, if I get it working the way I want it, will be a core system in its current form. I mean, this is we're writing real stuff, so it pays to take the time and do it right. And so if I can get it to reasonably process a rule set that you could tell the MVC, hey, I want you to make a dagger, and it knows how to do all the things to make a dagger, then we've got some interesting things to work with, whether we use all of those capabilities or not. But as it is, I think that the toy version we created before, which was the complicated planning test, has a lot of rules to search, and even still, it manages to solve that in 22 iterations. So it goes through the tree and it solves that in 22 iterations. And it figures out it needs to walk to the chest, get the route from the chest, do all that stuff. Now, it doesn't know locations of things. It doesn't know what, that's like we did this. It's a complicated test, but it's pretty basic. It doesn't know a lot of things about the world. And it's not parameterized. But the point is that we're getting somewhere. And each time I go through this and I find a problem, a lot of times that problem comes with a new optimization. Though I got to tell you, I was getting really discouraged last weekend. I really did. Last weekend, because we had like the long weekend, I spent all day Sunday slogging through debugging because I did a simple thing. I added the idea of expansions. So one thing that let me see if I can restore my whiteboard. Sounds relatable, fetching things from different containers. Yeah. Yeah, it's me. Remember me, guys? Oh, now I'm signing in as somebody else, aren't I? Maybe that's not what I wanted to do. Can I log out and log back in as me? Jeez, I hate menus that change while you're moving over them. Continuous ball speed. There we go. This is the way. I really hate UIs that move around while you're mousing over them. It's so frustrating. And yeah, and so many UIs do this now. All right, where's my live stream notes? There we go. So when we were playing with the rules for the bird. Oh yeah. Oh, stop. When we were playing with the rules for the Gafen last time, and we had it dropped the 3 pieces of food and it picked the food because it did this. Let me bring up the code. I'll show you what I'm talking about. Because oops, set up controller. So this is kind of the old way, and we would do this a different way now potentially. But the way the rules were set up was, it wanted to eat food. In order to eat food, it needs to be near food. In order to be near food, like this produces near food, it needs to walk to the food. So it needs to find some food. So it needs to know what the food target is. And so in order to find a food target, this requires, this produces a food target from the closest types of food. So closest types, the idea would be it would query the world for objects that are food that are nearby. But the way I set it up is it just grabbed the first one. And really this is not the way you would do it. Even a Gafen is smart enough to know that the food that's right at his feet should be the one he eats over the the one that's 2 meters away, even though they're all within kind of his radius of awareness. And if he needed to eat 3 pieces of food, he'd probably eat them in the most logical order that gave him the least amount of motion. So I added the idea of expansion, which instead of having to pick one, this sort of find food would take all of these and sort of split them into different branches in the exploration. This is what I was talking about before, or maybe I wasn't talking about with you guys, but I was trying to explain to my wife. When we're doing like spatial navigation, when we're doing walk paths and stuff, it's really easy to visualize, because you can picture the thing walking around, and you can imagine, if this was a city street here, you can imagine him walking around all of the different places, trying the different paths. But when you're talking about a rule set like this, it's or a rule set like this is not the position. We're not really walking through this in the sense that we will never come back to a certain place. We will come back to a place all the time, because we're kind of exploring different states. And so the locations we're exploring are not just the location in here, but they're all the properties that happen to be in effect at that time, and all of the previous actions we took to get there. That is what makes a state unique. Yeah, sort of where we are in this tree, where we are in the stack, where we visited already, what our current actions are. They're all part of the state, and so it's really tough to represent visually the exploration of the space. And I was going somewhere with that. But if we could, so you say, let me take these expansion rules as an example. So if we go back over to the expansion test, so we create some simple rules. We want, what do we want? We want to have a target. We don't know what we're going to use a target for something. Yeah, what is this doing? Let me actually run the test real quick. A lot of times reading the rules, they sometimes look upside down to me. Yeah, so we look around and we find, oh, here it is. Yeah, so we look around, we open, we get. So let's say we wanted to get an item out of the chest, right? So we want to get the object. In order to get the object, it requires that the contents of whatever container are not empty. And so we need to pick one of the containers that has something in it, and then we'll change. Am I looking at this backwards? So this is my problem. I always look at it backwards. Get object needs contents. This looking container gets the contents, and select neighbors picks which container. Yeah, okay. from a logical perspective, we know we need to get a particular object, any object in this case, it doesn't really matter what. And so we require some kind of container that is not empty, that has objects in it, right? That's our requirement. What we end up changing is what we're holding. We actually pull the object out of the container. And so that's where we say get this from that, right? This is part of the parameterization I did. You can actually query the context to build your actions. And so then what would produce, we require to know the contents of some container. And so this one is the one that changes the contents of that container. And what it's based on is actually, we know a target container, we're going to grab its contents. We're going to grab the contents from target container, the children, from target container, we're going to shove them in this contents object. Nowadays, actually, I could skip this whole step, but and so then we open. So that gives us the action to open that container. We're like, ultimately, that's what we really want. Is we want to be able to have the action to open the container, because it might be locked. You might not be able to open it. There might be other requirements. And so from there, we need to know what our target container is. And so now we have this new thing, which is this select nearby containers, which takes nearby containers, which is it queries the world for the containers around us, and it expands nearby containers into target container, which means that when we hit this, we started with, it always unselects the pencil. And now we've got the, so let's Control Z. Okay, it remembered my color selection. So we started, we're going to select, we found 3 chests, and so we're going to branch, we're going to try the different, we're going to try different rules from each of these chests. So, from there, then we explore all the other rules. From there, we explore all the other rules. And so we'll find the best chest for that particular point in the hierarchy. And it could be that we get down here somewhere in our exploration and we have to select these again, in which case, we'll select them again and it'll branch out the 3 chests and we'll explore again. If you had to get one object from one chest and one object from another, you'll explore all the different options again. And hopefully the cost is set up in such a way that if 2 objects are in the same chest, that you'll get them out of the same chest because the cost of that particular path would be the cheapest. And so that's what I haven't quite gotten to yet, is figuring out the costs, relative costs of different actions. Moving your focus from one chest or having to walk from one chest to another is an action that requires a cost. And right now all actions cost 1, and there's no accounting for the fact that something that's far away is far away and something that's close is close, that costs less. I do believe that right now it would be smart enough to know that getting the object out of the same chest is faster, because it wouldn't even have to walk to it. It's already at that chest. Anyway, when I originally started all this, I had a lot of very specific a lot of very specific things like, targets and blah, blah, blah. I had a lot of very specific context values is what I call them, right? Anything that has to look up a particular world value. But as I go, happy Saturday. As I go, I've been narrowing it down because I've added the ability to get fields from a particular object. So don't need so many of these things. So like I refactored in one of my tests, the things I was using temperature for, I don't have a special temperature one anymore. I just use field queries. That, in fact, over here. Right, so like whatever you're holding, you're going to be holding a rod, and that rod, whatever you're holding, has a temperature greater than or equal to 200. So we no longer have like a special temperature value, because it got really weird, the dependencies. If you start having things like that where you have a temperature that's based on the thing you're holding in your hand or some other object, then when you change what is holding left, you also have to invalidate all of those, whereas now it's automatic. And this also gets us to the point where what these comparisons, these predicates, the comparison, the temperature greater than or equal to temperature, or temperature greater than or equal to 200, can directly correlate with something that modifies temperature, increases it. right? Right now I know that. Right now I can only check that. Oh yeah, some other thing produces exactly 200. I can't say that it gets it closer to 200, right? If you needed to hold it in the forge 5 times, I can't figure that out. Like if the action of holding it in the forge only raised it by 10 degrees, you might have to hold it in the forge a bunch of times. Right now, holding it in the forge just raises the temperature to 200, and maybe that's realistic enough. But take the eating, for example. The Gafen eating a piece of food might not fully satisfy its hunger, and so maybe it needs to eat 3 pieces of food. That kind of thing. I can't do that now with this because it's directly comparing the result of a particular change to this predicate, this test. Whereas now that I've started creating my own test classes instead of embedding code in here, it means I can be smarter about that. I know that something that's going to set a value or increment a value can match a greater than or equal to predicate, because it knows eventually it could get there. It's getting it closer. So when I'm building this, I know that I can make that. Where's the temperature here? Somewhere in here is the temperature. At any rate, I know that I can make the. Yeah, here it is. Temperature. That temperature greater than or equal to 200. I know that I can technically hook it up to not just something that would set the temperature to 200, but something that could increment the temperature, might get it closer to that greater than or equal to 200. So I can build these sort of looser relationships. Because getting rid of those relationships at all and just using like the field or whatever turns out to search the tree a lot. Like you go 306. This plan to find the same solution as it did before takes like 368 steps instead of the 22 it takes now, that kind of thing. Anyway, ramble. But the point is, we're getting close to some really cool stuff, and so this is where I've been building. And we might continue here just a little bit. I kind of want to build in the expand stage. Yeah, to be honest, I don't know what to work on right this second. We could go back in the visual and maybe build up. Oh, I could show you after last time, because I think we just roughed in the basic UI. I actually fleshed all that out, so now we actually have a decent debug UI. I don't know if it's perfect yet because I haven't had to debug any rules through it, but I will show you what it does. There's some things I'd like to change about it, even still. All right, so yeah, go and start the simulation. Okay, so last time we had it, I think my chair has lowered down. So last time we had it so that you could, start the AI and you could click eat and it would drop some food, and then you're in this like planner debugger. Now it actually shows like stuff, right? Our pending goal is this and that, and the state is we've got no current state at this time. So we done it to our first step, and so we just tried the goal proposal. We didn't have what we needed. We had to branch at the eat food rule, and so now that's our pending rule. And in that pending rule, the state is that we're hungry. We've got a hunger of 5. And so we can kind of see, yeah, so this is what it changed as it. So we step again, and now we're at, this is like the place we are in this rule tree, is we're at the goal, eat food, walk to food. And remember, this is upside down because we're working backwards from our goal. And so, yeah, so the last proposal was eat food. We needed a food target. We needed to be near something. So then the branches to that were to walk to food so that we could get near a food target. And so that's what our next pending action is. A lot of times there would be multiple pending. Our rule set only has the 3 rules, and they're all chained together. And so then this tells us that, yeah, so we just processed the walk to food proposal. That still no plan yet, because we're just it's still in the pending. We've got to head back up. You'll see. Anyway, so the hunger is still 5 because we haven't done the action yet. But we did find some food. Yeah. That's interesting. Why class? Anyway, and so yes, so this is the branch we made for find food. Yeah, so find food is going to be the next one we check. Yep, find food finished the thing. So find food filled in the rest of our stuff, and that allowed us to pop back up. I kind of wish that it would let us pop a step at a time, but it's more efficient. It just can pop right back out. So that is part of that iteration. But anyway, we finished the plan. And then it dumps what our final sort of planning state is. And I don't know why this is class here. I've messed something up in my definitions. Let me just double check. Oh yeah, if you click anywhere outside of the window, it gets rid of it. So let's see. One of these guys is doing something strange. It's this one. Get class, get simple name is just returning class. That's funny. So let's just do that. Okay, so that'll recompile. Now if we run through this again, start the AI, eat. Yeah, I meant to show you that as we're stepping through, you know, we can look at what the state is with that particular pending goal. If we had more than one pending, it would show different lines, and we could look at the state of each one of those, sort of what it thinks. So this state is like the planning state. It's not really modifying the world. In fact, that was something that affected last weekend's design, is because I couldn't make a decision on a certain thing, and remembering the fact that this state is not real. We're not modifying the world. We're like exploring our options, and so we've got kind of this in-memory state, pseudo state of the world that we're using just to keep track of the rules that we processed. So anyway, yeah, so we stepped through, and now, yeah, closest types, food, yeah. So now we got that. And we found our final thing. And yeah, we can't execute it yet. And we've reached the thing. So that's what I was doing. And I think we can change this now to be an expand. And then we'll end up trying more things. Trying to think. So then find food. Right now we're just picking the first one. And what is doing that? That is the closest types, is just picking the first one. So for a second, let's change this. Yeah, and we won't even sort them. We'll just return them. And so this is now a list. And this should break our code at the moment, because so if I tried to run it now, it's going to break. It shouldn't succeed now. Yeah, see, now closest types has all of the things in it. And so food target has all of the things in it, and it's going to fail because that's not a... Yeah, so we're going to keep looping. Oh no, we're done. There's no plan. That's what it is. That's another thing I need. So like the UI should probably show that we failed. And it currently doesn't. So anyway, we can, now that it's doing the right thing, we can turn this into an expand. And let me steal the syntax from that other so that I don't screw it up the first time. So I think it's just expand what we want to set. Yeah, so like before, we were just setting a food target to whatever the first value was. But what expand does is it's going to set a food target to each of the, oh no, I got this backwards. It's going to set a food target to each, yeah, expands this into this. So it'll branch for each of the different foods, and so we'll pick one, and we should see more pending this time, and I'll show you. Eat. Okay, so step. Okay, so we need to eat food to satisfy our goal. We need to walk to food in order to eat the food, but we still don't know which food. We need to, yeah, see? Now we've got 3 find foods. Yeah, and so the state in this one is that the food target is entity 12. The state in this one is that the food target is entity 13, and the state in this one is the food target is entity 14. So each of these branches will try for a piece of food. Now probably we're just going to pick the first one, which I imagine would be entity 12. And there's no, again, there's no different costs for distance. That's something we'd have to build in. But anyway, so yeah, we branched 3 times. And so now we are trying. Our last goal was the plan. We got a plan. So that's the other thing. Is like I don't show when we failed and I don't show when we succeeded. The only way I know is that step won't do anything anymore and I could execute. So I really want this UI to maybe change the color or something to green or red to show that we succeeded or failed or something like that. But yes, so we picked. We're going to look around and we found all these things. We found these 3 items of food. We walked to. Well, we would if we ran the actions, right? The actions we got were look around, we find these 3, we walk to 12 and we eat 12 because that's the one we picked out of these. And we could have picked them based on distance or any other things. That's the cost of the action to getting there. If one of these was up the thing and one of these was down here, the one that's down here would be preferred because it would cost more to get up to the ledge and so on and so forth. So that's what that expand does, and it's super useful. So now that we've used that, we can yeah, find food, look around, found, yes, awesome. Okay, and we can start using the there's field-based predicates and functions now. I don't think we'll necessarily need the functions. Oh, import static. That's what I want to do. Static dot star. I think this is how the syntax goes. I don't know if Groovy uses the same. I don't use that too often, to be honest. Okay, so in here we should be able to replace this with the equals, and we could just say type name equals food, capital F food though, or we're gonna be upset. One more parentheses. So that should be fine. Everything should still work, but let's test it. So start the AI, eat, step, step, step. Should be one more. Like, yeah, we got our plan. Look around. Walk. Oh, we didn't eat. Oh, we got one more. Oh no. Uh-oh. Yeah, so I screwed something up. Because now it's just looping, trying to find a better one. So EQ type. Oh, I know. In order to resolve properties like this, you need to you need to tell your world how to resolve those properties. So when we create our our context, the planning context. So we need to tell it, there's the object and the property, and so you want to do like this. And I actually don't know if this is going to work because the way the entity IDs are defined. But and you can make this as complicated as you need to resolve those. Start AI eat. Step, step, step. Okay, is it going to find the food? Nope. Yeah, it's not. It's going to eventually fail. Yeah, no plan. It tried all the things and didn't find a plan. Yeah, so this is kind of the integration I have to think about. So if I change this to object dot prop, it should work in theory, but it's a little less reliable in the face of different kinds of, anyway. Okay, we've got the thing. Step, 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 step. Nope, we still didn't find it. Yeah, so that is, this is failing to return what we want it to return. And so this we have to debug through logging. And we're inside, we have a log. Okay, cool. Return log info object get prop equals. Alright, oopsie. Oh, I didn't close my parentheses. Alright, let's try again. Okay, one more time. We should have gotten one from GOAP agent driver. Yeah, I wonder if we're even... It's not even executing that code, so something gets lost before then. But it's true that I hadn't tested this with the entity system indirection yet. But that's interesting. It's not even going there. Maybe I did this wrong. EQ type name. There's always the chance that it's not running my code at all. Let me just make sure it's really running. Because we should have at least seen the world resolver engage. Okay, nothing there. Alright, I'm going to have to kill this and add a bunch of debugging to the planning context. I got to figure out why it's not sorting this out. It's very strange. And this is what I've been doing. Basically, I try something that should work. It doesn't work. And then I go track down why it doesn't work. And so here we are evaluating value. We should have a property key. And so context get value. This is usually where I find that I've done something. I should probably just make these trace logs so that I don't have to constantly. I probably want both. So I don't have to constantly add them back every time I want to check something. And then we checked the world. And so we will recompile this. Watch it be something dumb like I didn't install the latest library and this just works. Alright, we'll try again. Quiet chat tonight, but we got 5 viewers on according to YouTube. Are any of you living in the area that's going to be affected by the giant snowstorm that's supposed to start tonight, depending on who you talk to? Our grocery store, it was completely out of eggs. I wasn't there to buy eggs. I just thought it was funny. Like, the shelves were wiped clean. Yeah, we are too. We're here in Northern Virginia. So, you know, calling it Snowmageddon or Snowpocalypse. Oh, nice. You send some over to us. Melt our snow for us. Okay, so I start the AI. I think I did, and then eat. Oh, no, I didn't start the AI. Start the AI. Eat. There we go. Alright. Alright, step, step, step. And then one more should get us to where we try to do the thing. Okay, so get near type name. We found this and we resolved to null. And the world resolved to null and it didn't even call us. That is not right. We didn't get a print line or anything. So it's not running our code. So usually that means that Paul's live stream brain has done something dumb. Yes, Paul's live stream has done something dumb. I created this trap for myself because we had the old try to eat method that was actually just going to run all the things and didn't let us step through. And then I turned another one which just creates the planner and then lets us step through one at a time. And so I edited the wrong one. Edited. I love that word. It's so funny. Edited. Okay, so this was like a bug in my prototype code. So now step, step, So we got all the things. Now we should just find it, and we should... Oh! Kaboom! All right. Yeah, what this means... It should have at least logged the thing before it blew up. No such property prop. Oh, for class entity ID. Oh, yeah. Stupid. So now it actually might work to do this. What I'd have to do is, yeah, what is the... This is why I was doing this before, right? Yeah, so even my log was going to fail. Okay, let's try again. Good times. So, you know, in the olden days when I actually worked in an office, you know, there could be the idea that, oh, there would be too much snow, I won't be able to go into work on Monday. But I've worked at home for like probably going on 20 years now. At least 15, right? At least as long as I've been working on Mythruna, I've been working at home. And so no, we just keep working. So I don't get an extra fake holiday. All right, so step. Is it going to blow up? Step. No! And it actually worked. So the problem with the way I've just done it, had to do the 2 days in office. Oh, nice. Yeah, the people I work with these days are actually not even nearby. Like, I would have to fly there if I needed to work in their office, or drive like 4 or 5 hours or something. They're in a different state. So yeah, 2 days a week they have their mandatory in-office days, and I'm like, that doesn't apply to me, and doesn't apply to like 80% of the other people I work with either, because they are also distributed. So we just work at home. But that means, like, if Snowmageddon comes and the roads are 3 feet of snow, or, you know, a meter of snow or whatever, we'll still be working. All right, so that's working, which is good. Little detour down debugging. Yeah, so what I should do is I should comment this out. Just, I don't want to lose it, because eventually we might want the single click version, but this is going to save me from making that mistake in the future. So anyway, this new way, and I could probably just do this. Right, so that works. And so then the other thing we can try is changing this to be, what is it? Add number, I think. And we can just say -1. I think that works. And okay, I was gonna change all the other ones too. Uh-oh. Woo! Compile error. Oh yeah, we had, so somewhere back up here, it failed to compile. Error, start AI, no signature method, add number. No one gets in my way as much as I get in my way. Okay, so step. Yay! What do you say we tweak this UI to change the color to green when it comes up with a plan? To let us know. I don't know, we may want to still leave pending up, because it might be useful to see what we left in the queue. But I'm just thinking, like, goal or something can be highlighted green or red when we, yeah, let's change, where did we put that UI stuff? Down here. Okay. So I gotta remember where I put all this stuff. Okay, so that is last proposal gets proposal info. Proposal title is, I think, what we would want to change. And so let's make some colors. Success color. Color RGBA green. Fail color red. And we're going to set the default color to whatever it was when we created it. Default color equals proposal title dot get color. Okay, well, we'll hope that's right. And then somewhere we know when we were successful or not, because we know when we're done. So if we say, when do we know when we failed, though? Oh, we're done and we either succeeded or we failed. That's what it is. So in here, we'll say proposal title set color fail color, and we printed the plan out. That's fine. But we'll say success color, and then whenever we start and we set a plan, we're going to set it back to default color. Okay, let's try this. Alright. Start AI. Eat. Okay, step. Step. See, yep, this is still set the same way. Step. Still set. 9 point. Yay! Our goal was achieved. And now we have a plan. Yay! And I can't make it fail without, well, I can hack the rules to make it fail, but okay, now at least know we when we have succeeded. And so the next logical step would be to somehow have it pick the closest one. And we don't want to build that into here necessarily. We want to have that be sort of the cost of the action. And here's another issue that I can't determine in this rule set. I don't know where we currently are. So I can't tell. Well, there's a lot that's wrong with this particular rule set at the moment because it was based on the old way of doing things. Anyway, okay. Here's what we were doing. We were converting everything to the new form. So let's go ahead and finish that, and then we can delete a lot of this extra code I've added. Okay, so this is going to be the same predicate. That's nice. So see, we get to reuse a predicate. Yeah. So because we're not actually using, okay, and then this is another one we can change, and instead of, I think we already have just a not null that we can use. And yeah, so that should work. Let's see if it still works. Start ADI, eat, step, step, step. One more step. Yay, we found our plan. Look around, find the food, walk to it, eat. Okay, so that's working. I should be able to just delete these old ones. One of the issues that I came across is, and it doesn't affect us here, but when we create these actions, this is actually a factory. This is code. That's what these little curly brackets mean. We've created code here that we're inserting as a custom factory to make an action. And it has access to the context, so it can grab things out of the current object state or planning state. Same down here. And so these could be real actions we could create. In fact, maybe we could play with that today. I don't really know. And so then eating would do more than just, yeah, so maybe we could make some actions. Right, we've got an hour. So instead of just returning strings, we could return real actions that the driver would run through when we hit execute. And I already have, since I made those jump, I already have the idea of what an action should do. So we could, yeah, so an action will just, see, where's character action defined? Right there. And it will loop until it's done, I think. Jump, done. Alright, so this is not really the way it would work, because we don't have like a scripting system and other things, so we're just going to kind of hack something together real quick. But we should be able to then make our little puppet do things. Oh man, my stomach just grumbled. Yeah, so let's trying to decide the best place to put this. We'll leave the entity stuff up together. We'll define our actions up here. So we'll have a walk to action. And yeah, we'll want the animation pump for sure. Target. Oh wait, we probably do want move force. Oh yeah, we need move force. That's given to us. Yeah, wait. Let me see how jump action's used again. No. We don't need to do, we need the body and the anim pump. And then jump action. Yeah, that's the move force. Yeah, we don't need that. And it's going to just, boy. Yeah, okay. Okay. So we don't need this. We do need target. And probably we want a min distance. We'll just hard code it for now. We don't need to care about time. We probably do want to care about last location. Okay, so then walk action, walk to action. To action. Like 3D target. Step target equals target. Oh yeah, force scale. Let's go ahead and calculate the force scale. I think we're going to want that later. Okay, and then update, we would figure out what our current location is relative to where we want to be. We don't need last location, just occurred to me. Excuse me. Oh yeah, so that's, yeah. I don't think we necessarily need alright, we will use force because then when we stop applying it, it's going to disappear right away. I don't want it to overshoot whatever we're doing. Again, we're kind of this part really is hacky. We're hacking in these actions to just kind of directly force the mob, like no pathfinding or anything. It's just using a jetpack to force it in the right direction. But like 3D dir equals target subtract body position. Yeah, okay, and then and I believe, okay, we'll ignore orientation for a second. Eventually we're going to do a look at. So let's do body, normalize, local, or wait, first, let's do this. Double length equals dir.length. If length is less than 10 centimeters, we're done. Return false. We don't have to keep going. Otherwise, dir mult local 1 over length. I don't remember if I have a divide local or not. So, so now we know what our direction is. And body, add force dir mult force scale. All right. Return true. Okay, so now we have at least one action. Let's see if it compiles. Okay, and what we can't do yet is queue these up. So, like, you can set one at a time, but that's it. And then context in this case is the body context. We should have that. Okay, so let's just let's make our rules. So we'll do a different does, and we'll say new walk to action. Oh yeah, we won't have all the things we need unless we put them in the context. Okay, we'll do this for now. We will add an initialize. That takes these parameters. To move this down too. All right. Okay, so now that lets us be able to create a walk to action, which can take the food target location and I think that works. It won't work. I won't do anything yet, but I think that will let us create it. Let's add it to string so that we can see it in output and it won't look dumb. Walk to target. Oops. What am I forgetting? I am forgetting. We're not using it yet. We just want it to create it. Oh, I meant to check and make sure I actually have a location. Yep, I do. I created one. Sure. Okay, so this should, in theory, at least give us the action in the plan. So start AI eat. Step, 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 step. Okay, yep, we've got our walk to action. It knows the location to walk to. Cool, cool, cool. And then if we had execute, what we want to execute to do, let's just see if it even works. In fact, yeah, if we execute, okay, we want to say I think we're not using this anymore, right? So this update body we're not using anymore. Then it's up to us to do the action stuff. Yeah, so let's go ahead and make the chain. So let's say character action plan or actions, and then int current action equals 0. And then we'll say public void execute list plan, and actions equals, we'll make a new action thing for plan each I'll say action if action instance of character action actions.add action. Okay, and then we'll say current action equals 0. And here, oh, we could have just used the movement input too. Let me see something. It's like, I wonder if jump would have still worked if I left it in. I'm gonna, okay, anyway, let me finish my train of thought first. Okay, let's take this out for a second. Let's find jump. I wonder if jump would work if I put it back in. Because, no. If jump gets the body context, it's the thing. I don't think it requires manual control. But let's see. Nope. Okay, so we already have access to like character actions and stuff. We just don't know. Yeah, nice. Okay. Alright, so we can use character actions, and I can set this back to false, but then it will remove the thing and won't actually remove it, I think. So now we'll have an empty... Yeah. Now our jump thing will break, so we'll just have to ignore it. It's not real. Pay no attention to the man behind the curtain. Okay, so then... Yeah. Let's enhance our actions to have an is done. And so we will set done equals false. Done equals true. Is done, return done. This dot done equals false. Okay, so now if we... Well, first let's hook up execute. So we have an execute button down here that's not doing anything. And otherwise, so we would call oh yeah, neat. We don't even get a way. We don't even know who we're planning for. So we need to know who the driver is if we're going to be able to call things on it. And so then when we set the plan, it doesn't make sense to have an execute button if you can't call the thing. So agent, GOAP agent, execute, cannot spell, execute planner.plan. And let's just make sure that that's hooked up correctly. Do I have a log? I do. Info execute plan. Alright, let's see if I've got everything wired correctly. It's not going to do anything. Uh-oh. Nope. Oh yeah, I haven't fixed the set plan. Set plan needs to pass this. Eat planner. Who's okay? Wherever we're calling this. And then so this needs to know who we're calling. There we go. Let's try that. All right. Start the AI and eat. There we go. Step, 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 step. We run. We got did not call. Oh, we didn't call execute yet. Execute. Boink. Oh, kaboom. Whoa, that blew a big bada boom. Oh. That's dumb. Okay. Alright, let's try again. We're going to start the simulation. Simulation. Create the mob. Boink. Center the camera. Let's zoom in on him. Start the AI. Eat. Step, 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 step. Execute. Okay. Okay, call our execute. We got all the things. Okay. So now we can try to make it do things. And actually we want to set that to -1 and wherever we set the plan. Okay. Add a little bit of more hacking here. Alright. If actions equals null. Okay. If actions not equal to null, or if actions equal null, we're just done. We're not going to have to do anything. Return. Alright, otherwise, action equals actions. Oh, if current action less than 0, no. Do we know our context? Yes. Cool, cool, cool. What do I want to do here? I want to say like I did this so that I would know the first time we were in case I wanted to do any initialization. But otherwise, action equals actions dot current action. If action is done, current action plus plus. If action, current action greater than or equal to actions dot size, actions equals null. We're done with them. Return. Otherwise, we need to grab the next action, and we need to set that on the character if it's not already set. Actually, I think we can just won't that work? Let's see. Worst that'll happen is they'll just fail. Okay, let's create the plan and execute the plan. Uh-oh. Cannot get property position on null object. Oh yeah, we didn't initialize them. Okay. That was the other thing we had to do. Action initialize, and to that we need to give it the body. And the anim pump, which I think are on the context. Too many things in the same file. No. What is driver? Maybe driver has it. Yep. Okay, so then initialize driver dot body driver dot anim pump. All right. Let's try it again. Center camera. Okay, start AI. Eat. Step, step, step. This is where it would be good to have the single shot again. Doink. All right. He's working. He's walking towards it. Did he finish? I really should have. Yeah, he walked towards the thing. He was already close enough, to be honest. Yeah, so let's update the things to say oh yeah, so here's one of the things I can do. If current action is less than 0 or action is done, then yeah, no, I still have to have the both of them, unfortunately, because the other things I've done in the hacky way. So that's unfortunate. Because what I'd like to do is in one place, what I could do is say action, and then down here nope, that doesn't work either. Yeah, okay, except I just want to say here, I'll just do this. If context character action not equal to action log info starting action. Alright, so now we'll be able to see what it's doing if it had multiple steps. Start the eat there. Step, 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 execute. Uh-oh. No such property character action. Action. Getting in my own way again. Start AI eat. Step, 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 step. Execute. Okay, so it's starting action, blah, blah, blah. And it's walking over to that thing, and eventually it gets to where, yeah, the shadows do weird things. Need to fix that. Okay, and it should have finished. And it doesn't say when it finishes, unfortunately. Log info finished action. Alright, let's try one more time. I just really want to see the log that it's finished. I wish I could control him again to move him over here somewhere. Anyway, start AI, eat, step, 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 execute. Okay, so he's moving over there, starting, he's walking, 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 walking. And he never seems to finish. Alright, a little more logging then. Because you know me, I love my logging. I mean, we must be getting close. Start data, eat, step, 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 execute. Distance, oh, because it keeps moving. Right, as we get closer to it. And then our force is so small, I guess, that we don't move it anymore. That's weird. Yeah, so we need to grab the target location. We do. Maybe we need to clone it. We shouldn't have had to do this. I'm not convinced that this is the issue. And I hate when our hack code is what we're messing with as a center camera. Oh no. Start eat. Step, 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 execute. Yeah, see, why do we not continue going? Oh, I bet I know. It's because our force... No, our force should be always the same. Unless I've screwed something up. Log info dir force. Alright, start AI, eat. Step, 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 execute. See, we move right to its spot. And then, oh, I know why we're never getting there. Because we're doing a 3D distance and not a 2D distance. That's why. This will work for now. It's technically not correct. So center camera, start AI, eat. Step, step, step. One more step. Execute. So he should walk right to that location and stop. Boink. Yep. Stop. Yay! That was harder than it needed to be. And then I think there is an eat animation. let me see what I'm doing with anim pump, because where am I setting the current animation? In anim pump, set current action, current anim, current animation. So when I'm setting the info jog, okay, so I just wanted to see if they're, so I think the Gafen has an eat, and so I think anim pump is automatically updated. Maybe not. So animation info, movement animation. Set current action. So we definitely want to steal this. But what I'm concerned about is who updates that. Is somebody just telling the anim pump to update it all the time? I have a specific reason for doing this, so hold on. Somebody is updating the movement mode update. So movement mode update is setting the current animation speed and we don't set the anim pump movement animation. Movement animation. We set the speed, but we don't call update on it. So I'm trying to figure out who is updating the anim pump, because somebody has to be telling it what time it is. Like beyond set current action, something has to be telling it to update. And I don't know if that, it must be built in somewhere. Okay, so let's make a let's make an eat action. Eat, so let's see. Let's just steal all of this for a second. We don't need it all. So let's say eat action. And what are we going to eat? We're going to eat an entity ID. Yeah, we don't need the clone here for sure. We don't need force. We do need done. We want probably a time. Like how long we're going to eat. Double time. This dot time equals time. Double. Let's call it duration. And then we'll have a separate time. Alright, and then so when we initialize, we set done, We don't need force. We do need time equals 0. We don't need any of this. We need to eat. And so we say anim pump set current action eat 1.0, and then we say time plus equals step. I cannot type. We must be almost done. Oh yeah. If time is greater than or equal to duration, return false. We're done. Otherwise return true. We need to keep going. Okay, and then down here, when we create our actions, we can do something like this. Eat action, and we just pass it the value, not the location. It will get the it doesn't need the location. Will we blow up? Alright. So start AI eat step 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 step. Oh, kaboom. Did I not call it eat action? I did call it eat action. Eat action. New eat action. That takes a entity ID. What am I missing? Public eat action. Eat action. Oh, duration. Try to get fancy, get in my way. So let's have him eat for 3 seconds. So dumb. Hey, I still got Pepsi. It's getting kind of lukewarm, but see, if I've done this right and I've set the rules up correctly, then we ought to be able to have it, the eat action, remove the food, which we haven't done yet because I just don't want to have to reset up the test every time. Okay, so let's step, step, step. Wonder which one's going to go for it. Step. Oh, okay, we blew up again. No such property, force scale. Yeah, okay. I didn't remove something else. Ugh. You know, it's getting late because I'm making so many dumb mistakes. We're getting close to the culmination of all of tonight's work, and so we're going to be making lots of dumb mistakes. Oops, no, we just want to start the simulation. Gafins, create mob, boink. Okay, center the camera. Start the AI, eat. Let's plan to eat. Oh, they didn't go scattering very well. Step, 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 step. Yay. It didn't blow up. And we got eat. We're going to eat entity 12. Execute. We'll move over there. And then we're going to eat. Look, he's eating. But he never finishes eating. Why not? Okay, before the log goes too far. Let's see, why not? He originally did. Finished walk 2, started eating. Starting eat. Because we never set done. That's why. Now, also then, oh yeah, so he's gonna sit there pecking at the ground. Okay, so it's nice to know that works. But we're gonna want him to face that whatever he's eating. And then at the very end, I think I have a global entity data thing. Did I make one? System. No, I didn't. I wish I had. Maybe I did for the other things. Nope. Alright, so we will cheat. We will super cheat. Eat action ed equals system entity data. This is such a cheat. So ugly. So then when we're done, we'll go ahead and ed remove entity target. Okay. Yeah, so start at AI, eat, step, execute. Okay. Yeah, it never changed his, okay, he ate it. It's gone. See? It went away. Yay. Alright. And he finished this time. But now we let's let him face where he's going. Because that's getting annoying. I don't think my quaternion does not have a look at, so we're gonna have to, yeah, I think I've done this before actually. Quaternion, nope. Alright, well, we're gonna cheat here. Okay, we want okay, quat d def facing equals new new quaternion look at dir.to vector 3f comma vector 3f unit y. We have to tell it what up is. Okay, and then we want body orientation set new quat d facing. Okay, so that should make it look in the direction that it's walking. Okay, so let's try start AI eat step. Yeah, there's only 2 to choose from this time. So let's execute and see where he goes. Yep, he's going that one. He eats it. He eat it. Okay. But I want him to face while he's eating it too. For some reason he jumps back to his old orientation. But let's add the facing. Yeah, I think it's because body context is keeping the... Yeah, it's the yaw, pitch, roll thing. Alright, well, no, there's no easy fix for that without completely ripping out the old. So we'll at least make him face what he's eating. That way if it moves, it'll still face. So target dot location, subtract body position dir y. We can just say normalize local. We don't need all this crap. Oh, in fact, that other was wrong too. This needs to be... This needs to do it before... No, that's actually right. We haven't multiplied for scale. Okay, so we should be good. I think. Alright, let's get him to eat the last piece of food. Start, eat, step. He's going to plan out. It's a simpler plan this time. There's only one. Only one piece of food. Step. Hey, go eat it, man. Do. He's not walking. No, he's going to stop. Uh-oh. Did I forget to zero out the... I did. I forgot to zero out the Y. Alright, so he's like doing handstands to... Yeah, because we're not using the anim pump. See, ideally we'd use steering and stuff. I'm just, again, I'm just hacking this in. And so while we're hacking, let's just continue the hack and say walk at 0.25. I'm just guessing. I have no idea. It's going to put new food down when we start it because I did set that up right. I should have anyway. Yeah, it drops new food. Okay, so now step, 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 step. We have 3 foods to choose from. Pick one. Now go get it, buddy. Go get it. He's going to get that one. It didn't walk, though. Okay. And he faces the camera again, because again, there's that old controller that's driving everything that really wants to be steered. Yeah, so if we hit execute again, it's going to try to execute that same one, but it's gone. It shouldn't do it. All right, let's eat, step, 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 execute. Yeah. Okay. Oh, he is walking. He's just walking really slow. Okay, he is actually walking at the correct speed almost. Okay, so he's going to eat this one. Boink, boink, boink. I mean, obviously it's not correct, right? It's not lined up with the food at all. All right, so let's do it again. Eat. Eat. Okay, step. 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 We've got our goal. Execute. He's going to walk over there really slowly. Probably he could walk a little faster. Alright, so we've like basically hooked it up. You know, I've spent an hour hacking in something I'm going to rip out, but because what really needs to happen is for the walk, we need to really be setting a steering implementation that steers towards the object. That way, if the object is moving, you know, it leans in, and he needs this stop before he gets all the way there, and so on and so forth. But it's working, right? The basics are working. And I got to show you a little bit about this dialog and how it works. Yeah, I got rid of all our proposals so we can't see what the state, and that's okay. Yeah, so it's working pretty cool. And I think that's, oops, yeah, I think that's where we're going to end it. Yeah, he, like, they're hold on, let me get him back to his idle state for a second. Alright, so he, yeah, so, like, the idle animation is every now and then they look at the ground and he looks at scratches his feet a little bit. But yeah, that's exactly what he's doing, because they're food driven, so they're always looking for something to eat. So they'll scratch the ground a little bit to see if there's something there. His little like idle animation. So I think that's where we're going to end it tonight. We're right about 11 o'clock. You probably need to get some dinner and stuff. But yeah, that's a pretty cool thing. So this is probably where we'll be working next week also. I'll just be fleshing out the back end. Hopefully we can get to pretty soon. I may flesh out these actions a little bit more so that by next time we can just start writing actions, because I really like to get to the point where maybe we can take the maybe we can take one of these guys and plop some anvils and stuff around and have them walk, you know, some chests and anvils, and have them walk through the actions. So within like maybe 2 weeks, maybe we can get to that point where we're actually having one of these guys walk through some real actions with some objects in the world and, you know, pretend to execute scripted actions and things. But anyway, that's where I'm going to end it. So, you know, the usual. Thanks for watching. Like, comment, subscribe. Comments on the videos are really nice. I'm really close to 1,000 subscribers, so if you know friends who are interested, please get them to subscribe. Otherwise, I hope you all have a really productive week, and I will see you guys next time. Thanks.